Today I'm going to answer a question from a student by the name of Aurelia Roman. I hope I pronounced her name correctly. And her question is on the video about parallel circuits. And the gist of her question is, can you explain the formulas that we use to calculate resistors in parallel? Well, let's take a look at those formulas real quickly. The first one is going to be what we call the product over sum, which is going to be R1 times R2 divided by R1 plus R2. Now I like this formula when the numbers are fairly easy that you can do in your head, because this is fairly quick to do in your head. Let's give an example. Let's say, this will be actually too easy. Let's say we have two 10 ohm resistors in parallel. So let's draw the circuit just because we can. $10 ohms and 10 ohms. I'm not going to write the omega next to the 10 because you know what I mean. You know, when you see a resistor and a 10 next to it, that doesn't mean 10 microfarads, it doesn't mean 10 millihenries, that's going to mean 10 ohms. So a lot of schematics leave the omega out. So there's 10 ohms and 10 ohms. Now we know that whenever you have two resistors in parallel that are the same value, that the total resistance will be half of either one. So the total resistance here will be 5 ohms. We just know that by looking, but we can use that as a check against the formula. So the formula is going to be 10 times 10 over 10 plus 10, and that's going to equal 100 over 20, and 20 goes into 100 5 times. So yes, 10 ohms in parallel with 10 ohms is 5 ohms, and we just calculated that out and it came to 5 ohms. So that is the product over sum formula, and it was very easy to do in our heads. The disadvantage to this formula is you can only do two resistors at a time. So for example, if I have a third resistor, we'll make this one 5 ohms because we can make the math very easy if we do that. So we would have to do the formula a second time. So we do it the first time, do the 10 ohms in parallel. That gives us a total of 5 ohms for those two. Then we can do the other 5 ohm resistor in parallel with those, which gives us 2.5 ohms. And we can do the calculation again if we want to. So that's going to be 5 times 5 over 5 plus 5, which equals 25 over 10, which equals 2.5. So that formula works, but we had to do it twice to do 3 resistors in parallel. Now, as far as why this works, I don't know. I'm not a master mathematician. I suppose I could talk to one and find some insight into why that formula works, but I will show you where we can apply it other than electronics. Let's say we need to paint a house. And we're going to paint it with both Bob and Alice. Let's say Bob can paint the house in 30 hours and Alice can paint the house in 20 hours. So we're going to do the math. That's going to be 30 times 20 over 30 plus 20, which is going to be 30 times 20 is 600 over 50, and that equals 12 hours. So Bob and Alice together will take 12 hours to paint that house, where one would take 30, the other would take 20. Now let's try to find just a little bit of insight into that formula. We have 30 times 20 over 30 plus 20. So we know Bob will take 30 hours, Alice will take 20 hours, and we know together they're going to take something less, and we know that together they'll take something less than the lowest number. So together they'll take something less than 20 hours. So we take 30 plus 20, and that's going to be 50, and we're going to divide that by something. But that's not how the formula is working. I suppose I could talk to a mathematician and do some mathemagic and find out how this formula becomes that formula, but we can't work this one out easily, at least, but it does turn out that if we do the product over sum, that we do get the answer. So anytime we have a job being done where we have two entities doing it and we want to find out how long they take to do the job together, or anything similar to this, we can use that product over sum. So it's not only applicable to electronics. By the way, there's a question going around on the internet. I'm not going to repeat it, but you might see this, where it's a house painting problem where there's 3 people painting a house and you're supposed to calculate how long they take together. It's not exactly the same problem because they don't tell you how long each person takes, but they're going to say how long each one compares to the other one. And if you are really good at mathematics, you can take this formula and turn it around to find out how that works, but that's not the formula that works in this particular problem. However, if you look at the 3 people painting them and you do the numbers, you find out that they don't add up. Now, the formula that's used to actually solve the problem would solve the problems if the numbers did add up, but actually the numbers can't add up. In other words, the time that person 1 takes with person 2, and person 2 takes with person 3, or person 3 takes with person 1, the numbers they give you can't possibly add up. So just a little tidbit of information there. But it's a completely different formula to figure that out. But yeah, it does work if the numbers are correct. But anyway, if you have people and you know how long they take to do something, you can calculate how long they would take it together by the simple product over sum, just like resistances. And that's about all the insight I can give you into this particular formula. Now, the other formula is the 1 over 1 over 1 over formula. So we have 1 over the total resistance is equal to 1 over R1 plus 1 over R2. Now, I like this formula if I have a calculator handy, or especially if it's complex numbers that I can't really do in my head, because it's a lot easier to put this into the calculator. And another thing about this formula is you can expand it to however many resistors you need to expand it to. So I don't have to do it 2 at a time like I do with the product over sum formula. So to do this in the calculator, it's pretty easy. Let's say I have 10 ohms, and 5 ohms, just like we did before. So that's going to be 1 over 10, 1 over 10, 1 over 5. Add them together. So 1 over 10 is what? 0.1. 1 over 10 is 0.1. 1 over 5 is 0.2. Add those together. That's going to end up being 1 over 0.4. And that's going to equal 2.5. So we can do the math there in a calculator. That's pretty easy. I can just do, resistor 1, take the reciprocal, store it. Resistor 2, take the reciprocal, add it to the stored number. Take resistor 3, take the reciprocal, add that to the stored number. And I can do that as many times as I want. Then take the sum of the stored number, take the reciprocal, boom. So it's very quick and easy to do this in a calculator. So if I have multiple resistors and a handy calculator and it's complex numbers I can't do in my head, I'll definitely use this particular formula. But let's take a look at where this formula comes from by drawing our circuit again. R1 is 10 ohms. R2 is 10 ohms. And R3 is 5 ohms. Now, we didn't care what the battery was the first time, but we're going to care now. We're going to make that a 10-volt battery. Now, what we can do is, if we know the battery voltage, we can find out what the total resistance is by using Ohm's law. Let's go ahead and do that. What we need to do is calculate the current through each resistor. So we have 10 volts, 10 volts, 10 volts, parallel circuit, so the voltage is the same everywhere. So we have 10 volts across 10 ohms. What's the current through that resistor? That's going to be Ohm's law. If you know your voltage, divide into it. 10 goes into 10 one time, so we have 1 amp. Same thing here, 10 volts, 10 ohms, 1 amp. And over here we have 5 volts, 5 goes into 10 2 times, and we have 2 amps. Now, what's the total current for the total circuit? We simply add the currents together, Kirchhoff's current law. So 1 plus 1 plus 2 is a total of 4 amps. So there are 4 amps leaving the battery, and 1 amp goes this way, 1 amp goes that way, 2 amps go that way, and they come back as 4 amps again. But now that we have our voltage and our total current, well, what's the total resistance that would give us that current? Once again, we know our voltage. Ohm's law, we divide into the voltage. So 4 goes into 10, what? So 10 divided by 4 equals 2.5. So that means that the resistors together are 2.5 ohms. Now let's do the problem again, but instead of using the voltage, let's say we don't know the voltage. Let's say it's just a circuit without a battery there yet. We just simply use an assumed voltage of 1 volt. And let's watch what happens. Let's erase these currents here. So now we have 10 ohms divides into 1 volt, Ohm's law. That's going to give us 0.1 amps. So we have 10 ohms divides into 1 volt. So there's 1 volt divided by 10 ohms. That's going to equal 0.1 amps. So 0.1 amps here. 10 volts goes into 1 volt, gives us 0.1 amps. Now we have 5 ohms dividing into 1 volt. 5 goes into 1, it gives us 0.2 amps. So now we add those currents together. So we have 0.1 amps, 0.1 amps, plus 0.2 amps, which is the same as 0.1 plus 0.1 plus 0.2. Starting to look familiar. We add those together to get a total current of 0.4 amps. So our total is 0.4 or 0.4 amps here. And then we divide that current back into the voltage to find out what the resistance is. So 0.4 goes into 1 volt, and that gives us 0.4 divides into 1 volt, giving us 2.5. So, as you can see, the 1 over 1 over 1 over formula is simply taking our Ohm's law, and instead of doing it one step at a time, we break that down into a complete formula. So if we did that with the 10 volts here, erase our currents again, what do we have? We have 10 divided by 10 plus 10 divided by 10 plus 10 divided by 5, which equals 1 plus 1 plus 2, which equals 4. 4 goes into 10, 2.5 times. So we simply took our Ohm's law, Ohm's law, Ohm's law, Ohm's law again, came up with the number, or we can imagine that's a 1 volt battery. 10 goes into 1, 0.1. 10 goes into 1 volt, 0.1. 5 goes into 1 volt, 0.2. 0.1 plus 0.2 equals 0.4. That goes into 1 volt, giving us again the answer of 2.5. So it's simply taking the Ohm's law, and instead of just thinking of it as one entity at a time, I'm putting them all together into a single formula. So that's what the 1 over 1 over 1 over formula is. It's just a derivative of Ohm's law. And you can see how we can work that together there. So that's why that particular formula works. So that's the insight I can give you into that formula. I can't go much deeper into the product over sum because I would have to be a mathematician to do that. I'm not a very good mathematician, and that's not what this course is about anyway. This course is about making electronics easy, and I hope I have done that. So I hope that answered your question. If it didn't, please ask again. Please keep asking those questions in the comments. I answer as many as I have time for, and sometimes when I don't, someone else does. If you found this video useful and informative, please give me a thumbs up down below. It really helps the channel. And subscribe, because that not only informs you when I put new videos up, but it really helps the channel also. And a big thank you to my patrons at Patreon. I could not make these videos without your support. If you want to help me put these videos online and keep real vocational education free at vocademy.net, you can go to patreon.com/join/vocademy and pledge your support. And again, a big thank you to my patrons who make this possible, and a big thank you to everyone for watching.